Hello and welcome. This is the third video in Darton College's Science Department's Flip Learning series from P3 Force and Motion. This is acceleration. To get updates about when the video is being released, please follow us on Twitter on Darton Science or use the hashtag DartonFlipped. So the aim of this video is that by the end of it you should be able to write a definition for what acceleration and velocity are. You should be able to calculate them both, and you should be able to understand and calculate relative velocity. So firstly, what is velocity? Essentially it's just speed in a given direction. So you can have a positive velocity and a negative velocity, and they mean the same thing. It's just speed but in direction. So the equation to work out velocity is the same as the equation to work out speed. Distance divided by time. So in a context here you have two cars, one travelling 40 miles an hour with a positive velocity and one travelling 40 miles an hour with a negative velocity. They have the same speed, but that only tells you half the story, because if they started at the same point, an hour later they'd be 80 miles apart rather than right next to each other. So their relative velocity is the difference between the two things. Basically, what you end up with is 40, add 40 to give you a relative velocity of 80 miles per hour. Again, it's the difference between the two cars that we need to be concerned about. In this situation, the difference between these two cars is 140, so the relative velocity here is 140. In this situation, from the perspective of the people in this car, the train is travelling 10 miles an hour faster than it, so the relative velocity is 10 miles per hour. From the perspective of the people in this car, the difference is much greater. Because they're travelling in the opposite direction, the relative velocity is 150 miles an hour. Moving on to acceleration and deceleration. Acceleration and deceleration are the rate of change of speed. So you start with speed, and then you need to do a rate of change. So you divide it by time. That gives you the units meters per second, or meters per second squared, which hasn't translated very well here. So if there's an acceleration of 2 meters per second squared, means that for every second that vehicle is travelling, its speed increases by 2 meters per second. So in the context here, something that's accelerating at a rate of 2 meters per second squared for 2 seconds increases in speed by 4 meters per second. Add that to the initial speed of 3 meters per second there, and in this context here, the final speed is 7 meters per second squared. The only other thing to be aware of is acceleration is speeding up and deceleration is speeding down or slowing down. Here's another example to try. The car increases from 0 to 18 meters per second in 6 seconds, so the change in velocity is 18 meters per second. The time is 6 seconds, so the rate of change, the acceleration, is 3 meters per second squared, or meters per second per second. Another example to try. The change in speed of the cheetah is 20 meters per second. Divide that by the time it takes, 2 seconds. That gives you an acceleration rate of 10 meters per second squared. Another example here, we have a Formula 1 car that goes from 0 to 27 meters per second in 1.7. So the speed is 27. Divide that by time, which is 1.7 seconds, which gives you an acceleration rate of 15.9 meters per second squared. Like any equation, you can rearrange it and use it in any form you want. So if you knew that a car could accelerate at 5 meters per second squared, and it accelerated for 5 seconds, you could work out how much its speed changed. Using the thumb method, you cover the change of speed, which leaves you with the equation that you want. Acceleration was 5 meters per second, and it took 5 seconds. So that would give you a change in speed of 25 meters per second. You'd have to add that to whatever the original speed was. So, in summary, acceleration or deceleration is a measure of the change of speed, and you calculate it by dividing the change in speed by time, so it's a rate of change. Velocity is speed, but it has a direction component, and the relative velocity is the difference between two velocities. Don't forget to bring your purple exercise books with your evidence that you watched this video. I've tried to make it a little bit quicker for you guys, so hopefully you won't be complaining that it's 10 minutes long this time. Thanks very much. Cheers. Bye.